Hey folks, we have another opportunity to do some learning on YouTube, and today what we're going to be doing is looking at and learning about the area of a triangle. So our goal for today is to be able to develop and apply the formula for the area of a triangle. I'm going to show you why the formula works, how it works. So here's the problem I thought that we would work at first. And what it says is that my wife and I want to paint our deck with sealant to protect it from moisture. The blueprint for our deck is going to be found below. We'd like to try two different types of sealant to see which one works best, and the cost of the sealant is going to be $2.25 per square meter. So the question that we're going to be looking at is, what is the cost of painting each half of our deck? And so what I thought I would do is I would show you this sheet, which is the blueprint. So if you can see, this is the blueprint of our deck. So the length here is 10 meters, a couple other numbers here, 15 meters, 4 meters, and 6 meters. Now, yesterday we learned a little bit about the area of a parallelogram. So we know a formula that we can use to help us solve for the area of a parallelogram. Now we know that area equals length times width. Okay, and so we have this formula, we have this diagram, which hopefully we can recognize that it's a parallelogram. And we know these two numbers here. We have 6 meters and 10 meters. 10 meters is going to be our base, and 6 meters is going to be our height. So actually I need to rewrite this formula as not length times width, but base times height. Sorry about that. So we do our plugging in of numbers, so that 10 meters times 6 meters equals 60 meters squared. Okay, so I know that the overall area of this deck here is 60 meters squared. Now, what my wife and I want to find out is what about the area of just half of the deck, which should be simple enough. We just take 60 meters squared and divide it by 2 to give us 30 meters squared. So half of the deck is only 30 meters squared. Now we're not done yet because we still need to find out what the cost of half the deck is. Now we were told, we read earlier, that it's $2.25 per meters squared. That little dash means per, and then we see meters squared. That's the units. So what we can do is we can plug in some more numbers, and we can take the area of half of the deck, and we can multiply it by $2.25 per meters squared. And once you've done that, you get a grand total of $67.50, which is the cost of sealing half the deck. And again, if you want to know the total cost of sanding the deck, you can use 67.5 times 2, which gives you, once you do $67.50 times 2, you get a grand total of $135. Okay, so hopefully what you see is now we've also built up with two triangles. Okay, so hopefully what we're noticing is that a parallelogram, quadrilaterals can be split up into two different triangles. Now, the reason I'm using a parallelogram is because it has this B in the H, which I think is nice. And so what we're going to do is go over a couple of examples of figuring out the area of a triangle by using parallelograms. Okay, and so what we're going to do is we're looking at these two triangles, and what we're asked to do is we're asked to calculate the area of a triangle by forming a parallelogram. So we have these two triangles, and what I've done is I've combined them. They have the same measurements, they're the same size. I've combined them into a parallelogram over here. And so what we have is we have this parallelogram that has the base of 15 meters and the height of 4 meters. And we know the formula, which is area equals B times H. That's the formula for the area of a parallelogram. And so what happens is you do your substitutions. The base is 15 meters and the height is 4 meters, and 15 times 4 is 60 meters squared. Now, we don't want to know we know the area of the parallelogram. We want to know the area of just the triangle. So let's just split that number into 2 again. So we say that the area of the triangle is going to be 60 meters squared divided by 2, which equals 30 meters squared. Now, often it's appropriate, in case you're forgetting, to join up 2 identical triangles and form this parallelogram, because you know this formula here. Okay. Now there's a divide by 2, and I'm pretty sure that dividing by 2, or that the formula for the area of a triangle shouldn't be anything new. I'm pretty sure you guys did it last year. And so what we're going to do is move on to this second example, which is calculating the area of a triangle, just using the formula. So here we have a parallelogram ABCD, and what I want to do is solve for the area of triangle ABC. We have the 2 dimensions that we need. We have a base, we have a height. So the formula we know starts with base times height. And if we remember from up here, once we've gotten the area from base times height, we have to divide it by 2. So what I'm going to do is I'm going to put this in brackets, and I'm going to put a divide by 2 at the end. Okay? So what that shows us is that this formula, area equals base times height divided by 2, will tell us the area of a triangle. And when we do our substitutions, we get 9 centimeters as the base times 4.5 centimeters divided by 2. Remember, with order of operations, we bring stuff down from line to line, and the equal signs are lined up. Now, 9 centimeters times 4.5 is, I believe it's around 40. It's 40.5 centimeters squared, and then divide by 2 gets carried down. Okay, so we're doing multiplication division from left to right. Now, once we've divided 40.5 divided by 2, we get an answer of 20.25 centimeters squared. So this triangle ABC, which is part of quadrilateral ABCD, the area of that is 20.25. And this leads us to this formula, which is area equals base times height divided by 2, which is the formula that I want us to know. There are other ways to look at it. You could say it's like half base times height, or it's base times height over 2. They're all ways of showing the same thing. This is the one that I'm going to show to you guys, that I'm happy if you use it. I'm happy if you use one of the other ones as well, but that's what we're going to be working with. Okay. Now I know that we're running a little bit long. I want to show you a couple more examples of being able to use this formula. So I'm going to bring back my original pad, and I'm going to check over some examples together. So the instructions here say to calculate using the formula for the area of a triangle, half of the area of each of these parallelograms. So I've drawn out 3 parallelograms, and I've actually used a red line to divide up by 2. And so for each of these, we're going to do the formula, which is area is base times height divided by 2. And then my base here is 8 centimeters. My height is 6 centimeters. I'm going to put it in brackets, and I'm going to divide that by 2. I carry stuff down from line to line. 8 times 6 is 48 centimeters, and centimeters times centimeters is centimeters squared, divided by 2, which means the area of half of this parallelogram is 24 centimeters squared. So that's for that one. This one, again, is a slightly different looking parallelogram. I've divided it up with that red line. Okay, I'm going to use my formula, A equals B times H divided by 2. Do my substitutions. Base is 4 centimeters, height is 6 centimeters, divided by 2. So that's 24 centimeters squared divided by 2, which equals 12 centimeters squared. So the area of half of this parallelogram, or the area of the triangle, is 12 centimeters. Lastly, real quick, last example. The base is on a different side, but still the base. It's still 8 centimeters. The height is 2 centimeters. Divided by 2. 8 times 2 is 16 centimeters squared divided by 2, which is 8 centimeters squared. So 8 centimeters squared is the area of that parallelogram.